Hello and welcome. This is still Chapter 1, Section 2, Analyzing Graphs of Functions, but this will be Part B. So today's specific goals is determining the domain and range of discrete and continuous functions just using their graphs. We've done this a lot using domain and range, and we'll continue to do this throughout the rest of math. Again, if you forgot, even though we've done this like 3 or 4 times this year already, domain is the set of all valid inputs. So if we think back to that cryptic functions that we did as an activity, it is what x values you can plug in. Again, this is my x values. And then our range is what can get out of it, our outputs, which are my y values. Again, these could change depending on the situation. We might use other variables and other things, but in most cases we'll use x's and y's. So let's look at example 1, the domain and range of this discrete relation. What does discrete mean? First off, it just means it's not going to be continuous. It's just a finite number of different data points, which we only have 1, 2, 3, 4 different points. Hence being discrete. Continuous will be an infinite number of points. And what that means is like it could be something where it's just a part of a graph or a thing that goes like this. So we could have like from here to here. There's so many points in here that we don't even know how to count it. Well, it's infinitely many of them. So these would be continuous, and there's so many points that you can't count. They're infinite. These ones are 1, 2, 3, 4, hence discrete. So what is the domain, or what are the x values of this? Well, we just look down from the point, and well, our first point, we're going to put it in set notation. We're going to create our solution set here. So the set is -1, and then right here, from this point right here, we have +1, and right here we have 4. Notice how this is actually not a function because it has or does not pass that vertical line test. So now that we've done that, let's go ahead and do a range of values. A range of values, again, we're going to do a set here. Now we're just going to look at, I'm going to start from least to greatest. So we're going to start at -1 here. My y value is -1. Now we're at 0 here. We're at 2 here. And we're at 4 here. So my range of values, or my y values, are those. And don't forget 0. A lot of people tend to miss 0. So example 2, we're going to look at a context of a graph. We have a machine at a bakery poured out flour for 16 minutes. At the end of the time, the machine was empty, so it's starting at 400 grams and it's pouring out, and now there's none, and it goes from 0 to 16 minutes. So that's the context of this problem. So what is the domain of this? So the domain, and we're going to write it as a inequality for this. So we're going to say my x value is between and equal to what? So thinking about that, we can start here. It is actually equal to this number. X starts right here. So it's starting, so we're starting and equal to 0, and then it goes all the way up to 16 where it finally ends. So x, our domain, is going to be between 0 minutes and 16 minutes. The 0 is where we initially start. We have that 400 grams. And then we pour out that 400 grams until we get to no grams at finally that 16-minute mark. Now our range of values, let's go ahead and write that down. Range is the y value. So is the y, what is y going to be between and equal to? So again, we have 400 as our max. So we're starting kind of here, but we're going down all the way to 0. But we always go least to greatest, so it's not going down, even though the graph is. So it's actually starting and going upwards in that fashion where we have 0 all the way to +400 because it's always least to greatest. Now we should probably write this in interval notation because it's easily done, but this is good enough for now. So example 3 is a visual picture of a continuous function. Again, it's continuous where it's starting here and smoothly going through. There's an infinite amount of points that are in between here, hence continuous. Discrete is a finite set of points. Continuous is infinite amount of points. So how do I write this domain with this squiggly kind of weird looking curve? Well, again, we're going to start with our x value. So we are including that, and we're going all the way to here for my x value. So we're going here to here, and remember, I'm going to go ahead and write these as my open circles, and no, they're not. So if we think about it, this is a closed circle right here because we include it, and it goes all the way up to here, an open circle. So if you match this, we're just thinking about the x values here, and it's open circle. So we're going to write that as that interval notation, which if you think about it, it's inclusive here, and excluding that one. So our domain is going from that -3 all the way up to 2 and not including 2. Now the range is very similar. So we're not including that 3, and it's going all the way down to 4 here, and it's including that 4. Sorry, -4. So it's an open circle above, and it's a closed circle below. So we're starting from negative to positive here. Let me erase that and rewrite that because that's gross looking. So let's go ahead and put that open circle. There we go, like better. So again, if we think about it as a bracket, so this is a closed bracket, this is a round bracket, we go from least to greatest, so it's going from -4 all the way to +3. That would be my range of values, so -4 all the way to +3, and not including that +3. So just see if you can try that one, and then what we're going to do is a piecewise defined function, which will add a union of graphs. So go ahead and try this to find both the domain and the range here. Pause it, I will have an answer shortly. So hopefully you got that. We go from -3 to 3, not including, hence roundy brackeys, versus the square ones, which are inclusive. And then we go from -5, not included, right here, all the way up to +4. Again, always least to greatest, so always the smallest numbers on the left. That is a very common mistake that people have. So our last two examples, example 4 and 5, are going to be these piecewise functions. Notice how we have one piece and another piece. We're going to do exactly like we did before, except when we put them together, again, like kind of the addition of sets is our union of the intervals. So we're going to put them together through unioning them. So how do I do that? Well, I'm going to start with -4 here and go all the way up to +2, because this graph starts here at -4 and kind of goes to -2 with my x-axis. So that will be my first thing. I have from -4 all the way to -2, and I'm including that. And then again, to put sets together, in this case we're unioning them, so I'm going to continue that. And then if I look here, we're starting at -3, not including, and going all the way to +3 and +4, but not including those. So we're going to do +3 to +4 and not include those. So that would be my 2 range values. Now, sorry, my 2 domain values where we're unioning them together here. So the range, very similar. So we have +5 not including, we have 2 inclusive, we're going up and down. So again, going from here, it's going up all the way here. So we're kind of matching the highest point of this to the lowest point of this one. It's including 2 and not including 5. Same thing for this graph, very similar. It's not including that and it's not including that, so it goes all the way down here. So it's going from here all the way down to here, but not including those endpoints. So now we're going to put those two together with the union because there's a gap in between them. So if I go from least to greatest, again we go -5, not inclusive, all the way up to 0, not inclusive. And then we're going to union that with, well, we're starting at 2, which is including, and it goes all the way up to +5, not including. So we go from here to here. So let's move on to example 5, and I do apologize if there was a little ringing in the background. That was something I could not get out of this video, but let's keep going on. So let's do the domain and range of this one. This one is more interesting. So we'll start with the domain. I'll just put the range over here again. So the domain again, you will start here. It looks like it starts at this point. You go up, match it from here. That's the far right of it. Go ahead and match it right here. So this domain is actually not that big right there. It's going from -3 to -2 and not including either of those. And again, we're going to have to union the next one, which starts at 0 here and goes up to 2 and not inclusive. So again, this is 0 for my x value and 2. So it's going from 0 to 2 and not inclusive. So our domain is just those right here, but the range is where it's a little bit interesting, because if I go from -5, which is the one down here, all the way up to +5 right here, we'll put that open circle and we will continue that. It looks like so. But notice how this one in the middle is actually inside of that red. So this purpley magenta one is kind of inside of the one already here, so that doesn't really matter because it's being included in the red. So we only have to do the red part, which is from -5, not including, all the way to +5, not including. It's kind of like piecing the two together, but if we're adding the red one and this one, unioning it, remember we don't write the numbers twice, we just write it once. So it includes all the way from 5 to -5, or sorry, to -4, sorry, -5, yep, from -5 all the way to +5 here in the red, so that is what we're going to use. So please try and check this one on your own. I will have an answer shortly. So the domain is very similar to what we did before. The range is a little bit different where these two pieces kind of join each other. So it's starting from -4 and then it joins with the magenta one and keeps going up to +4. So it's all of this range here. It's like, again, adding these together. These kind of merge in the middle. As long as they merge in the middle, we don't recount them twice. We just say, well, -4 goes up to here and then it starts here and goes all the way up to +4. So it's going to be that one thing